Okay, grade 11s, let's answer a past paper question. So what we have over here is the graph of f of x, and they did not give us the value of b and c. We can see that there's a value of 1, okay? And the straight line g are sketched below. Okay, so we don't even know what the equation of the straight line is yet. And it says A and B are the points of intersection of F and G. Here's A, here's B, okay? A is also the turning point of graph F, so we can work out the turning point using that formula x is equal to minus b over a, and then working it out and then subbing it into the equation again to get the y value. It says the graph of f intersects the x-axis at b, which is 3 and 0. Okay, great. We got this coordinate point. Okay, I'm using my laptop, but in your people's paper, when you get something like that, you go fill it in over here for yourself. Okay, and then it says the axis of symmetry is x is equal to 1. We know that axis of symmetry, I explained it in the previous video, it's this line over here, meaning that our turning point coordinate is actually 1. Right, and we can substitute that into the, oh wait, we said we don't have this b value and c value, but if we had the b value and c value, we could substitute it into there and get the y coordinate, then we'd have it, right? Okay, let's continue reading. It says, oh, I noticed that there's a 90-degree angle here, so they're definitely going to ask us about some length over here. It says write down the coordinates of c. I explained in the previous video about this axis of symmetry thing. We know that from here, this part over here, which is 1, the distance from here till there is exactly the same as the distance from here up until C. So if this point over here is 3, oh, they said 3, yes. That means from 1 up until 3, there's 2 units over here. That means 1, that's where we are, minus 2. It's going to give me negative 1. My coordinates of C are negative 1. Okay, so let's write this down. 8.1. Coordinates of C are negative 1 and 0. Okay. Second question says, determine the equation of f in the form y is equal to x squared plus bx plus c. What information do we have? We have this information, which are two x-intercepts, and we got, do we have another random point? What else do we have? No, we actually don't have another random point. Let's just see here quickly. We have, oh wait, hold on, we've got that the a value is 1, so we can substitute it still. Let's show you. 8.2, we got y is equal to a into x minus x1, x minus x2. We know that this value over here is 1. How do I know that? Let me show you quickly. Second, x minus x2. How do we know that? Here it is over here. There is no alphabet a. There's a 1 in front of this x squared. So that's how I know that that value is, in fact, 1. I'm going to pass it through the two coordinate points. Remember, we know that x1 and x2 are the x-intercepts. Here's the one x-intercept, and the other x-intercept is b. Just writing it down for us, which was 3 and 0. Okay, so I'm going to just substitute that in. So y is equal to and then I'm going to multiply out. I don't have to write this 1 anymore. X times x, 1 times x, negative 3 times x, and 1 times negative 3, giving me 1 minus 3 is negative 2x minus 3. There's my b value, there's my c value. And we have done what they asked, which is to write down the equation of f in that format over there. Alright, next question. It says, determine the range of f. Okay, I gave you in the previous video that if it's a smiley face one, we just need y greater than or equal to the Q value. So this question here is for 2 marks, meaning that they're giving you a mark to calculate what the Y coordinate is over here, and then to say Y greater than equal to that. So we're going to substitute. Let's write it down. We're going to substitute 1 into here. How do I know 1? Because it was the turning point. Giving me -4. So my range, pick a smiley face, and there we go. Okay, question 8.4. It says calculate the equation of G in that form over there. We know that G is a straight line because they gave it to us here and we can see that it's a straight line. We also know that this M value over here is the gradient, and in order to calculate the gradient we need 2 coordinate points. We have this coordinate point, we have this coordinate point, so we're going to work out the gradient between those points. So M is equal to y2 minus y1. Okay, this here is going to be -4 minus 0 over 1 minus 3. I'm using the coordinates of A and B. Okay, A was 1 and -4, B is 3 and 0. Giving me -4 over -2, giving me gradient of 2. Now we just say y, and we're going to pass it through one of the points. You can either pass it through A or through B. I'm going to go through A, which was 1 and -4. Bringing this over, 2 times 1 is 2, bringing this side, -2. C is equal to -6. Y is in fact equal to 2x minus 6. They wanted this to be named, oh, they just said write down the equation in that form. You can name it g of x is equal to 2x minus 6. Okay, next question. For which values of x will f of x be greater than or equal to 0? That's asking, let me just move up here. That's asking where is this going to be, or where on the graph is it above the x-axis? Greater than equal to, I explained this in the previous video, greater than equal to means above the x-axis. That means it's this part over here and this part over here. So this coordinate point over here we said was -1, so it's all the values smaller than -1, and this coordinate here is 3, so it's all the values bigger than 3. So we're going to write this down. Resume. Okay, it's going to be x less than equal to -1 or x greater than equal to 3. Why did I include the equal to? Because the question asked for where is it greater than or equal to 0. Where is f of x greater than or equal to 0? Let us continue. The next question says where is f of x over g of x greater than 0? Let's decipher what this means. It's saying I'm taking the y value of f divided by the y value of g. I want to get a positive. Now in order for that to happen, okay, remember this part of working out, you don't have to show it. You can do it on your question paper, okay? You can do it somewhere else. It's asking where am I going to get a positive, and isn't, if you divide in two numbers, if I have a positive and a positive, it's going to give me a positive. This here is represented by greater than 0. That's option 1. Or option 2 is if I get a negative divided by a negative, that's also going to give me a positive. So these are my two options. So that means where f of x is positive and g of x, or where f of x is negative and g of x negative. I'm going to sketch this really quickly. this looks like this. Let's just sketch here. Like that. And like that, right? We're gonna color code now. So we're looking for where f of x is positive. That means all of this and all of this. We are looking for where g of x is positive. That's all of this part. Okay, wait, maybe I should use a different color so you guys can see. Just gonna, that's all of this part over here. Okay, and then for this one, where is f of x negative? Negative all of these values over here. And where is g of x negative? All of these values over here. Now we just got to see where the two solutions are, or the two colors are overlapping. Can you see only blue? Once it reaches this point, it's nothing. Okay, all the way up until this point over here, then it's blue and pink. So that means everything greater than this value over here, and we know that this value was 3 and 0. It was the b coordinate, so that means where x is greater than 3, that's one part of our solution. And then let's look over here. Let me draw lines to just separate important points, the turning point and that x-intercept, right? And you see all these values up until here, it's just pink. Okay, the minute it reaches this point, we got pink and this blue color. So that means our solution is all the way from here up until here, because there we got blue and the pink part. So that means this value here was -1 and this value here is 3. So our solution is somewhere in between here. So this is how solution would be looking. Okay, and then we know that it also includes, so these are our two solutions, either this or this, but we know that this solution over here and this solution are sort of overlapping. This one solution is saying up until 3, and then this solution is saying greater than 3. So doesn't that mean our final solution is going to be anything that is bigger than this value? The minute I have a value bigger than this, I'm going to end up with positive if I divide the two of them. So my final solution for 8.5.2 is going to be x greater than -1. And there we go. Okay, 8.5.2 says it says 8.5.3, sorry. It says where's the x value of f of x multiplied by the x value of x value of f of x multiplied by the y value of f of x greater than 0. So we're going to do a similar situation. This means we want a positive, right, multiplied by a positive. That will give us greater than 0. Or we want a negative multiplied by a negative. That will also give us greater than 0. Let's draw out our graph again. We are looking something like this. Let's draw out our graph again for option 2. And we are highlighting again. Okay. X, where is it positive? From this value onwards, it's going to be positive. And f of x, where is it positive? It's all of these values and all of these values. And then the second part of the solution, x, where is it negative? It's all of these values up until there. And second part, where is f of x a negative? All of that. Now we're just looking for where our solutions overlap. Okay, I'm going to divide it again for us into important points. There's the turning point, x-intercept. We're looking for where both the colors intersect. Can you see here up until this point it's just blue, then it's nothing for this little bit, then it's just pink, pink, and then from this point onwards it's pink and blue. Again, this point here is 3 and 0, so that means x greater than 3. Let's look at option 2. The side, let's divide it into the parts. That one, turning point, x-intercept. We're looking for where it overlaps. Oh, here it's just this blue, then it's blue and this pink. Okay, right? So that means here it works. Here it's just the pink, here it's just the pink, and here it's nothing. This point over here was -1. This point here is 0. So that means our solution is somewhere between -1 and 0. -1 and 0. Let's just double check that our solutions don't overlap. No, -1 till 0. Different to this. So that means or. And to write down our answer, we're just going to say x. Do this, x is greater than 3, or x is somewhere in between 0 and -1. You could have, if you wanted to, rearrange it the other way around so that it goes smallest to biggest, but this here is fine. Okay, and okay, now we have a bit of a difficult question. It says, for what values of p will that, I'm going to write this down quickly, 8.6, will x squared minus 2x equal p have non-real roots? Now let's look at this. This is looking very familiar. It's our f of x. Oh, where did we write that down? So find that we had f of x over here. It's looking somewhat like this. Okay, so that's down. It's looking like f of x had this part and it had -3 addition. Oh, wait, not like that. It was x squared minus 2x minus 3. This here was our f of x, right? So it's, and we knew that for our f of x it had 2 real roots. That's what we had. So it's asking how much do I have to shift this, because if I bring this over, this here is going to look like this, minus 2x minus b is equal to 0. This here is asking me basically how much do I have to shift this up or down in order that this particular graph won't cut the x-axis anymore. That's what it's saying, right? Now let's look at our parabola. Our parabola is looking something like this. If I shift this further down, I'm still going to get that. If I shift it even more down, I'm still going to get something like that. Even if I shift it 1,000,000 units down, right? Something like that, it's still going to come up and cut the x-axis in 2 particular places, okay? So that means I need to shift my graph up, because let me just draw this parabola again. This is what it's looking like. If I shift this graph up and up and up, okay, then I'm going to end up with something like this possibly. So I want to know how much I can shift it up. That's what I'm thinking right now, okay? Okay, so we're going back to our dreaded investigation that you guys did at the beginning of the year, okay? In that investigation, you guys learned this. We learned that the discriminant, and remember the discriminant was this over here. Okay, we learned that if this discriminant over here is actually less than 0, it gives me non-real roots. And that's what I was getting at from this thing over here. You guys even drew it in your investigation, that if you shifted it up, or if the discriminant was negative, then you were getting non-real roots, and you guys drew this, okay? If this discriminant is greater than or equal to 0, we end up with real roots. Okay, and we go a little step further. If it's actually equal to 0, it's real roots, but the roots are also equal roots. Okay, that means it would look something, this is touching on you people's knowledge of nature of roots. It would look something like this. It's touching here and there, meaning this value over here is both the same number. Okay, that's what it's saying. And if our discriminant is actually equal to a perfect square, I'm going to draw a square so you know what I'm talking, a perfect square, the roots are rational, not equal, but real, okay? And if our discriminant is actually not equal to a perfect square, then the roots are irrational. And that's what happens on your calculator, when you type it in a quadratic formula and you end up with something looking like, let me just type one in, something looking like this. When your answers look like this is because the discriminant is actually not a perfect square. Then you'll see your answers are irrational. Okay, coming back to what we were doing over here, this is a 2-mark question. It's saying how much do I have to shift the graph up or down, okay, in order for it to have non-real roots. So let's go back to our knowledge over here. We just need to make the discriminant less than 0 and get our answer. Let's continue on a new page. We got, what's this? It was x squared minus 2x minus b equals to 0. So discriminant is going to be b squared minus 4ac, which is going to be, this is my b value, negative 2 squared minus 4 times my a value is in front, 1. My c value is negative b, right? This here gives me 4. Negative and negative giving me a positive, and 4 times 1 times b giving me 4b. So this is the value of my discriminant. In order for it to have non-real roots, I'm going to write here, discriminant has to be less than 0 for So we're going to just take this and make it less than 0. And now we're going to solve. Okay, giving me 4b. Take this over, negative 4. Divide both sides by 4. 4b is less than negative 1. So anytime my value is less than negative 1, this b value over here, less than negative 1, it means I'm going to have non-real roots, which makes sense. Look here, we already discussed that we have to be shifting our graph upwards, isn't it, in order for it to have non-real roots. And let's go back here. This negative multiplied by this negative is going to mean it's a positive, meaning we're shifting our whole graph upwards. And if we shift our whole graph upwards, we have non-real roots. Okay, 8.7. It says T is a point on the x-axis and M is a point on the M is a point on F such that TM is perpendicular to the x-axis. Let's go look at that quickly. It said it over there. Here's T on the x-axis. Here's M on f of x such that there's a 90-degree angle. Okay, why did they tell you this? So that you know that the x-coordinate here is going to be exactly the same as the x-coordinate there. It's a perfectly straight line, okay? That's why they tell you either perpendicular to x-axis, or they could have told you that TM is parallel to the y-axis, meaning it's a perfectly straight line, and you can assume that the x-coordinate here equal to the x-coordinate over there. Let's go down. It says such that TM... Oh no, wait, we read that. TM intersects G at B. Calculate the maximum length of PM. Very similar to what I was explaining in the previous video. It's that AB determine the max length or min length between A and B. So P and M, that means straight line minus parabola. Let's do that. PM is basically equal to G of x minus f of x. G of x we said was, where's our G of x formula? Oh, here it is. 2x minus 6 minus our f of x formula we discovered over here, x squared minus 2x minus 3. I'm going to put it in a bracket. Minus 2x minus 3. Okay, why did I put it in a bracket for you? So that this negative, because lots of us make silly mistakes with that, this negative must get distributed to each one of them. Let's do this. 2x minus 6, negative in there, negative in there, and negative in that. Right, I'm going to re-simplify this by adding and subtracting like terms. 2 plus 2 Minus 6 plus 3 giving me minus 3. And now I'm going to complete the square. Take out negative as a common factor. Always divided by 2. And then we subtract the same thing. This here is going to be 4 divided by 2, which is 2. 2 squared is 4. Negative 4 plus 3 giving me negative 1. You can type it in on your calculator if you'd like. Negative getting distributed in front of the bracket. See, it didn't affect my sign in the bracket. Negative times this negative giving me a positive. Now we know, is this a maximum or minimum? Okay, it's going to be a minimum. A maximum. How do I know this? Because this is negative, it means it's a sad face having a maximum. Where's my maximum? It's at 1. So we're going to say, let's just read this question again. It said calculate the maximum length of PM. So we're going to say max. So we're going to put the therefore symbol is 1 unit. And there we go. We are done with this question.